Good day to all of you. Welcome to Easy Physics. Learn physics as easy as 1, 2, 3. Through this video, we are going to discuss some basics and fundamentals of logarithmic calculations, which is meant for students of classes 11th and 12th. In physics as well as in chemistry, you need to use logarithmic calculations in many places, right? Before we start using the logarithmic table, I would like to discuss two things. One is what are the basic formula which we will be using while performing log calculations. Secondly, how to express a number in scientific representation. The first thing is the basic and fundamental formula. The first formula is log of multiple of two numbers will be equal to log A plus log B. That is, by using logarithm, multiplication can be converted into addition. Second formula is log of A divided by B is log A minus log B. And thirdly, log of A power n is equal to n log A. This formula has got many applications. You can find out cube root, square root, or higher powers of a number. For example, if you want to find out eighth power of a given number, you can use this formula. Okay, I'll show you some examples of each of the calculations through this video, so that you'll be getting a more clearer idea. So these are the three basic formula which we'll be using. There are another formulas also, but in this video, we are going to discuss only these three formulas. Secondly, before we start using logarithm, we should know how to express numbers in scientific notation, which we have already discussed and studied in class 11th physics, right? I'll just brief how can you convert a given number into scientific notation. Firstly, the scientific notation has got two parts. One is a number between 1 and 10, which means always in scientific notation, always the decimal point has to be placed after the first non-zero digit. And then it'll be followed by 10 to an exponent. The exponent value depends on how many decimal places you are shifting. Okay. Another thing to be kept in your mind is if the number you are converting into scientific representation is greater than 1, then the exponent will be positive. On the other hand, if the number to be represented in scientific notation is less than 1, then the exponent will be negative. While reading the rules, it seems to be a little complicated since it's a, 2, 3 points written with long sentences, right? But if I show you one example, it becomes so easy, right? I'll just give you an example. If you want to convert the number 123.4 into scientific notation, the first thing you see is 123.4 means it is a number which is greater than 1, which means when you write it in scientific form, 10's power is going to be a positive number. Decimal point has to be shifted to a place where it comes after the first non-zero digit. The first non-zero digit here is 1. So you will be writing 1.234 into 10 raised to a positive number. Number is going to be how many decimal places you have shifted. Here you are shifting the point to 1, 2 places, right? So it will be 1.234 into 10 raised to 2. On the other hand, let me show you an example with a number which is less than 1. For example, 0.001234. Here, this given number is less than 1, right? First, you have to shift the decimal point, which should come after the first non-zero digit. Here also, the first non-zero digit is 1 only. So 1, 2, 3 places you have to shift, right? So the number can be expressed in scientific form as 1.234 into 10 raised to, you have shifted 3 places. And since this is a number which is less than 1, it will be -3, -3. Okay, now we are all ready to read a value from the logarithm table. Log of a number has got two parts. One is the characteristic and the second one is Mantissa. To find out the characteristic is nothing but the tens power in the scientific representation. For example, 1.234 into 10 raised to 2 log of this number means the characteristic of this log is going to be power of 10. Power of 10 is 2 here, so 2 point. Then Mantissa has to be read from the logarithm table. Logarithm table you can find behind the NCERT reader, or you can even purchase a small booklet which contains log and antilog values, right? A logarithm table will be looking like this. It has got so many rows and columns of values. The first column starts with 10 and it goes till 99, and the remaining columns are, here you can see 10 columns with values 0 to 9, and further 9 columns with the heading mean difference. It is also having the values 1 to 9, right? Now I will show you how to find log of a particular number. Let us take an example. If you want to find out log of 15.27, the first step is what? Convert or express the number in scientific form. 1.527, right? That is a scientific form. You have to shift the decimal point to this side. Since 15.27 is a number which is greater than 1, 10's power is going to be positive, right? So this number can be expressed as 1.527 into 10 raised to positive. How many places we have shifted? Only one place. So 10 raised to 1. This is the first step, which means the characteristic of this log value is going to be 1. Right, 15.27 I'm writing as 1.527 into 10 raised to 1, which means characteristic is going to be 1 point. Then you have to read the mantissa from the log table. For that, whether it is 15.27 or 1.527 or 152.7, always pair the numbers as 2 digits, 1 digit, and further 1 digit. Okay, so here I'm pairing it as 15 to 7. First column, in the first column you will see a 2-digit number, right? Starting with 10, 11, 12, it goes till 99. In that, here you are going to find out log of 15 to 7, which means you have to place the ruler against 15. Why I prefer you to use ruler or scale? Because these values are so crowded in the log table, right? In order not to misread the values, it is always better that you use a straight a ruler or a scale. So 15 is the first number, right? Then comes 2 is the second digit. Against 15 you should read the value which is coming under 2. It is nothing but 1818. I'll write the number 1818 here. And the fourth digit is 7. 7 means you should see in the mean difference column, the number which is coming under 7 is 20. So write this 20 here and add these two numbers. It becomes 1838, right? So this is going to be mantissa of the given number. Characteristic is 1, mantissa is 1838. So log of 15.27 is going to be 1.1838. If you want to find out log of 152.7, I don't use logarithm now, because 152.7 means 15 to 7. We know the log table. Only the characteristic will change, right? 152.7 means 10's power will come as 2. So the log of 152.7 will become 2.1838. So this is how logarithm value has to be read from the log table. The opposite function of log is antilog. Before we start doing any calculation examples, let us see how can you read the values from the antilog table. Antilog table will be looking similar to this, but here the numbers will start with 0 point something, right? And then it will also have the column 0 to 9 and further mean difference column starting with 1 to 9. Okay, with an example I'll show you how to read this. If you want to find out antilog of the number 2.8699, antilog is going to be opposite function of log. So here this is a characteristic, right? So whatever number is coming before the decimal point, that is a characteristic. How did we write the characteristic in log? We have taken 10's power, right? So while finding the antilog, whatever is coming as a characteristic, that can be written as 10's power. Here it is 2, right? So the answer for this is going to be some number into 10 raised to 2. Okay, so this characteristic is read and we can write it as 10's power. Now this value, the mantissa part, has to be read from the antilog table. Here further, you have to divide it into set of 2 digit, 1 digit, and then 1 digit. The first digit is what? 0.86. So you have to keep your ruler against 0.86 in your log table. The next digit is coming 9. So in the next column, you have to read the value which is coming under 9 against 0.86. It is nothing but 7396. So you can write it as 7396. And from the mean difference column, you see the number which is coming under 9. It is nothing but 15. So here you can write 15. So it becomes 6 plus 5, 11, 1, 4, 7. So 7411 is what you're getting. And always the answer of antilog is going to follow scientific representation, which means without thinking anything, you can place the decimal point after the first digit. 7.411 into 10 raised to 2. This 10's power we got from where? We got it from the characteristic of the antilog value. Hope this also is clear how to read the antilog value of an antilog number from the antilog table. Now I will show you some examples. How can we perform multiplication of two numbers quickly and easily by using log calculation? If you want to find out multiplication of 0.002345 and 123.4, first thing is write both these numbers as scientific representation. Here I'm going to write this as 2.345 into 10 raised to. This is a number which is less than 1. So 10's power is going to be negative. And how many decimal points you are shifting? 1, 2, and 3. So it will be 10 raised to minus 3. 123.4 means the number can be expressed as 1.234 into 10 raised to positive number, and we are shifting to 2 places, right? So 10 raised to 2. Got it? So this is the first step. Now we studied one formula. Log of multiple of two numbers can be written as log A plus log B. So which means in order to multiply these numbers, you can find log of this number and add with log of this number. Okay, so first we'll find out log of 0.002345 from the log table. Okay, this is the log table. So first part is characteristic. Characteristic is going to be minus 3. I'll write it here. Bar 3.2345 means you have to see 23, 4, and then 5, right? So first you look into the number column 23 and 4 means 0.3692. So I'm writing it as 3692. 23, 4, 5, right? So in the mean difference column, 5 corresponds to 9, which means 1073. 3701. So this is the log of the first number, 3701. Now you have to find out, add with log of 123.4, right? 123.4 means you can write it as 1.234 into 10 raised to 2. So characteristic is going to be 2 only. So you can write 2 point. Now 1234. So here 12.3 means this value 0.0899 and 4 corresponds to 13. So it is going to be 9 plus 3, 2, 12, 10, 11, 9, 0.0912. So I'm writing it as 0912. Add these two numbers, it becomes 3, 1, 7 plus 9 is 16, 4. Okay. Now, bar 3 plus 2 means it is going to be minus 3 plus 2. Minus 3 plus 2 is nothing but minus 1. I'm writing it as bar 1. So your answer is going to be anti-log of, because you have performed logarithm means in order to nullify this effect, you have to take the opposite function. So when you want to multiply two numbers, you have to add log of these numbers. Then after addition, take the anti-log of the answer. Okay, so this is your answer, bar 1.4613. Take the anti-log of 4613. Bar 1 means tens power is going to be -1, right? So just look at the antilog table. 10 raised to -1 you can write as it is, and antilog of what number you have to check is 4613. Okay, I'm just writing it here, 4613. Okay, first you look at 46, 1 means 2.891. 3 corresponds to 2, right? So 2.893. Your answer is going to be 2.893 into 10 raised to -1. So this will be the answer of 0.003465 into 123.4, whatever number we have taken. Okay, so this is how by using log you can perform multiplication. Okay, you can take, see, calculation by using log will become easy only through practice. So what you have to do is you can take any multiplication of any huge number which seems to be very difficult for you, take that and perform that multiplication by using logarithm and check with your calculator whether you are getting the exact answer or not. You will be getting accurate answer within no time by using logarithmic calculations. Okay, so this is how multiplication can be performed. I'll show you an example of division. If you want to find out 12.34 divided by 0.00345, you will take so much time using traditional method, right? So we can take log of a by b is what? Log a minus log b, which means you can write here as log of 12.34. I am writing it as scientific notation 1.234 into 10 raised to 12 means it is a positive, sorry, greater than one number. So 10's power will be positive. We are shifting only one place here. So it becomes 10 raised to 1 minus log of, again, this I'm writing it as scientific form, 3.45 into 10 raised to minus only because it's a number which is less than 1. How many places we are shifting? 1, 2, 3, and 4 places. So 10 raised to -4. Okay, after performing the subtraction, you can take the antilog of the answer which you're going to get. So 1.234 into 10 raised to 1 minus log 3.45 into 10 raised to -4. 1.234 into 10 raised to 1. Log of that value means the characteristic will be 1 only, right? 1 point. Now you have to check 12, 3, 4, right? 12, 3, 4 means 12 against 12. You have to see the number 3, 0.0899, and 4 is nothing but 14, right? 0.0899 plus 14 means it becomes 3 here, 9 plus 1, 11, 9, 0.0913. So the log of the first number is going to be 1.0913 minus, because since it is division, you have to subtract. Log of the next number will be, see here you have the characteristic -4, right? So I'm writing it as bar 4 point log of 34.5. The fourth digit is not there, which means you can leave. You can take only 34 against 5. Okay. So take 34 and 34, 5 means this number. 0.5378. So it will be 5378. Then perform the subtraction. 13 minus 8 is 5. 10 minus 7 is going to be 3. 8 minus 3 is 5. Here, I'm taking 10 minus 5 as 5. When you take 1 from here, this number is going to be 0 only, right? 0 minus -4. 0 minus -4 means it becomes +4, right? So your answer will be antilog of this number, 4.5535. Antilog of 4.5535 means 10's power will be coming as 4, because whatever number is coming before the decimal point, that will be the 10's power, right? Now you have to read antilog from the antilog table, 5535. Okay, this is the antilog table. 55.3 is 3.573, 55.3 and 5. 5 means 4 only. So 3.573 plus 4 means 3.577 into 10 raised to 4. This is going to be the answer of your division. Isn't it so simple? Instead of using that big division, you can convert log of the first number minus log of the second number, do the subtraction, and then find out the antilog of that answer. Simple, right? But obviously you yourself have to practice by taking more of these like of examples and check the accuracy of your answer by using calculator. Now I'll show you another example. We have studied one third formula, right? What was that? Log of a raised to n is equal to n log a. So log of 123.4 power 8 means 8 into log of 123.4. I'm writing it as 8 into log of 123.4 means 1.234 into 10 raised to 2. I hope now by now you know how to write the scientific form, right? 8 into this. Log of 1.234 into 10 raised to 2 means characteristic is going to be 2, right? So I'm going to write it as 8 into 2.123.4. We have taken it so much time. So it is going to be 0913. I hope you know by now, right? 0913. Multiply these two numbers, 8 and 2.0913. 3 8s are 24, remaining 2. 10 here, remaining 1. 8 9s are 72 plus 1 is 73, remaining 7, and 8 2s are 16. Now you take the antilog of this number. 16.7304 means while taking the antilog, this 16 will be coming as the tens power. You have to read from the antilog table what is the value of 7304. Okay. Antilog table is this. 730 means 5.370, right? 730 is coming this way. 5370, sorry, 5.370, 73 what? 04, right? And 4 corresponds to 5 here, number 5. So the answer is going to be 5.375 into 10 raised to 16, because while performing this multiplication you got 16 point, right? So whatever number is coming before the decimal point, that will be the tens power. So log of, sorry, 123.4 power 8. This will take so much of time, right, if you do conventional method. But here we have taken very less time with explanation. So imagine that with with more practice, you will gain speed and you will be able to find out the answer within no time. The answer is 5.375 into 10 raised to 16. The same can be applicable if you want to find out fourth root or fifth root or even any root number. Okay, this also can be represented, or here also you can use the formula log of a raised to n is equal to n log a. Here I'm going to write this as log of 123.4 power 1.4. 1 by 4 means I can write 1 by 4 because here in place of n you have 1 by 4. So 1 by 4 into log of 123.4 means 1.234 into 10 raised to 2. Right. So here again, I'm going to write 1 by 4 into 2.1213. We know already, right? 1213 means 0913. What you have to do is divide this with 4. It becomes 0.20 means 5, 9 means 2, 11 means again 2, 33 means 8, right? And up to 4 decimal points we can take 0.5228. And now you have to find out antilog of this number. That's it. While taking the antilog, whatever is coming before the before the decimal point will be coming as the tens power. Here it is 0, so which means the answer will be some number into 10 raised to 0. Antilog of 52 to 8 is what you have to find. See, this is the antilog table. 52 2 means 3.327. 8 means 6 only. So 3.327 plus 6 means it will be 13. So 333. 3.33. So your answer is going to be 3.333 into 10 raised to 0. 10 raised to 0 is nothing but 1, right? So answer of 123.4, the whole raised to 1 by 4 is going to be nothing but 3.333. Normal method will consume so much of time, right? So I hope some fundamentals and basics of usage of logarithm table is clear for you now. If you have any further doubts, please do write in the comment box so that I can make one more video to clarify your specific doubts. Thank you for watching my channel and have a wonderful day ahead to all of you.